Hello student, today we are going to learn what is the elements of interchangeable system. That means important terms related to limit, fit and tolerance. Elements of interchangeable system means some dimensional factors and limit which make interchangeable system technically successful. We know interchangeability is the capability of interchange. In large-scale production of items of assembly, any one component selected at random should assemble correctly with any other mating component selected at random. Okay. The elements of interchangeable system are: first, what is nominal size? It is the size of a part specified in the drawing as a conventional practice. A nominal size is the size which is used for purpose of general identification. For example, the nominal size of a hole and shaft assembly is 60 mm. Basic size of the hole may be 60 mm. Basic size of the shaft may be 59.5 mm. Okay. Now, what is basic size? Basic size is the size of a part to which all limits of variation, upper limit and lower limit, that is tolerance, are applied to arrive at final dimensioning of the mating parts. All limits of variation are to be applied for final dimensioning of mating parts. Basic size of a part is often the same as the nominal size. It is the size of a part to which all limits of variation are applied in order to get a degree of accuracy which needs practical requirement. Basic size is the same for both hole and shaft assembly when hole and its shaft assembly the basic size is same. Now, what is actual size? Actual size is the actual measured dimension of the parts measured by measuring instrument. The difference between the basic size and actual size should not exceed a certain limit. Otherwise, it will interfere, it will disturb with the interchangeability of the mating parts. Okay. Now, what is limits of size? This is the hole, this is the shaft. This side is the lower limit of hole size. This is the upper limit of the hole size. Difference between upper limit size minus lower limit size is called tolerance. This is the shaft. This is lower limit size of shaft. This is the upper limit size of shaft. Difference between upper limit size minus lower limit size is called tolerance. Allowance. Allowance is the difference between lower limit, this is lower limit of hole, lower limit of hole, and higher limit of the shaft. This is allowance. The extreme permissible value of dimension of a part are called limits of sizes. Okay. There are two extreme permissible size for a dimension of the parts, upper limit and lower limit. The largest permissible value is called upper limit or higher limit, and the smallest permissible value is called lower limits. Okay. Now, what is tolerance? Tolerance on a dimension is the difference between maximum limit of size and minimum limit of size. This is the maximum limit of size for hole. This is the minimum limit of size for hole. Tolerance, this is the difference between upper limit size minus lower limit size. The tolerance is equal to the algebraic difference between higher limit and lower limit, and has an absolute value without sign, no negative, positive sign. For shaft, this is the upper limit. For shaft, this is the lower limit. Difference between upper limit and lower limit, this is called tolerance. Example for a dimension 50 plus 0.2 minus 0.2. Here higher limit is 50.2, the lower limit is 49.8. Basic size 50. So tolerance is the difference between upper limit minus lower limits. Here tolerance is 0.4. Okay. Now, what is upper deviation and what is lower deviation? This is hole, this is shaft. This is hole, this is shaft. Basic size for hole is this size is the basic size for hole. Basic size for shaft, this is the basic size for shaft. This is the zero line. Zero line is the same for hole and shaft. This is the maximum size for hole. This is the minimum size for hole. Upper deviation for hole, this is the maximum size for hole minus basic size of hole. Lower deviation of hole, this is the minimum size for hole minus basic size of hole. Now, upper deviation for shaft, this is the difference between basic size and maximum size. This is basic size, this is maximum size. Lower deviation for shaft, this is the difference between basic size and minimum size. This is the lower deviation, this is the upper deviation. Now, upper deviation is the difference between the maximum limit of dimension and the basic size. Lower deviation is the difference in dimension between the basic size and the minimum limit of dimension. For example, 50 plus 0.03 minus 0.02. Here 50 is the basic size, upper limit 50.0.03, lower limit 49.98. So, upper deviation is 0.03 millimeter. That means maximum limit minus basic size. Lower deviation is 0.02 millimeter. That means difference between basic size minus minimum size. Okay. Now, what is allowance? Allowance, it is the difference between the basic dimensions of the mating parts. Mating parts means hole and shaft. It is the difference between the smallest hole size and largest shaft size. This is the shaft, this is the hole. Maximum shaft size 49.94, minimum size 48.96. For hole, maximum size 50.02, minimum size 50.00. Allowance is the difference between smallest hole size and largest shaft size. Allowance may be positive or negative. When shaft size is less than the hole size, then the allowance is positive. When shaft size is greater than hole size, then the allowance is negative. As per figure, allowance equal to smallest hole size minus largest shaft size. Smallest hole size is 50.00, 50.00. largest shaft size is 49.94. Largest
shaft size 49.94 equal to 0.06. This is the allowance. Okay. Now, what is zero line? A straight line from which the deviation are measured is known as zero line or basic line. It is a straight line corresponding to the basic size. The positive and negative deviation are above and below the zero line respectively. For positive deviation, it is the above the zero line. For negative deviation, it is the below the zero line. This is the hole, this is the shaft, this is hole, this is shaft. For hole and for shaft, this is the zero line. For hole, this is maximum size, this is minimum size. Upper deviation measure from basic size and maximum size. This is the upper deviation. Lower deviation measure. This is the minimum size. This is the basic size. Okay. For shaft, this is the zero line. This is the minimum size for shaft. This is the maximum size for shaft. This is the zero line. Upper deviation, this is the minimum size and zero line. This is lower deviation. This is the maximum size. This is the zero line. This is upper deviation. Basic size for shaft. This is the basic size for shaft. Basic size for shaft. Basic size for shaft. This is basic size for shaft. Basic size for hole. Basic size for hole. This is basic size for shaft and hole are the same for assembly. Okay. It is clear, my student. Thank you.